Okay, so the last one we did was the chickens in the mail problem. So we're going to go to 79. All residents of Pensacola are residents of Florida. So really the statement is an if-then statement is if you are a resident of Pensacola, you are a resident of Florida. And I guess it depends on whether there's more than one Pensacola in the United States. But I think they choose these so there's only one. We can check on Google Maps if we wanted to. Okay, so what's P? P is you are a resident of Pensacola. And Q is you're a resident of Florida. So what we're saying here is that this statement is equivalent to not P or Q. So you are not a resident of Pensacola, or you are a resident of Florida. So that's right, but I don't get a good warm fuzzy feeling about this, so let me think about it again. You are not a resident of Pensacola, or you're a resident of Florida. So if you are not a resident of Pensacola, then you are not a resident of Florida. So you're either a resident of all residents of Pensacola. Just don't like that one. If you're a resident of Pensacola, you're a resident of Florida. You are not a resident of Pensacola, or you are a resident of Florida. So I guess it's saying that if you're not a resident, well, we got to not use the if statements. You're not a resident of Pensacola, or you're a resident of Florida. Okay, I'm just going to leave it at that. I still haven't figured it out. So theoretically, that's right. The book says it's right. But okay, the next thing is we're looking to see whether two statements are equivalent. And two statements are equivalent if the truth tables are the same as far as the inputs and the outputs. So we're looking at two statements here. And the two statements are as such. So we're going to make a truth table. It's going to have 5 rows. And we're going to have 1, 2, 3, 4 columns here. And we're going to have 1, 2, 3 columns there. So we're going to make up one table, which is, let's see, 1, 2, 3, 4, 4 by 5. So we'll move that over here. Actually, we'll put them on top of each other. And then we'll create another table. We'll just clone this one, and then we'll have an extra. We'll just have an extra row, a column when we finish. So we're going to do this one, not P, then Q. So we have a P column and a Q column, and we have a P then Q column, and then we have a not P then Q. So again, we just populate it as we normally do, and we use the truth tables for the if-then statement, which is true, false, true, true, and then we take the negation, which is false, true, false, false. The second one is P union not Q. So again, we have P and Q, which are our input variations. And then we just have this operation, which is, oh, we got to put not Q in there. So actually, I did need the same number of columns, didn't I? Okay. So then what we do is we do not Q, which is false, true, false, true. And then we do OR between this and that. So we just need one true to be true. So let's write that in a P OR not Q. So we get true and false is true. True and true is true. False and false is false. False and true is true. And now we look at the final thing. And actually, I just realized I did something wrong here up here. So let me fix this. I think. No, I did that okay. False, true, false, false. According to the book, it says they're equivalent, but I'm not getting that. So let's see here. True, false, true. They say that, but then they're not right. So, okay, I want to pause here for a second because I don't understand why they're saying what they're saying. Oh, yeah, my problem was I wrote the problem wrong. I copied it down wrong here. So this is an intersection. So we have the intersection with not Q. So I did union when I copied that down. So we're going to do the union of these two. I mean the intersection of these two. And so they both have to be true. And so I would get this versus that. Well, it's false because only one's true. These are both true, so it's true. They're both false, so it's false. These are both, one's false, so you get false, true, false, false. You get false, true, false, false. And so they are equivalent statements. Okay, let's look at 85. So we have P and not Q. And we have not Q, then not P. If not Q, then not P. So again, we have two variables. And so we need 5 columns. And then we have, the first one we have 1, 2, 3, 4. So we need four rows. And this one we need 5 rows. So we have, 5 rows and 5 columns. So we need 5 each for the second one. So let's fill these out. P, Q, not Q, P, and not Q. True, true, false, false. I don't know why I did that. Ignore that. True, false, true, false. I should have moved these down one. Not Q is false. true, false, true, and then I use an and here, so both of them have to be true, and actually they're all false because there's no two trues together, so they're all falses. And actually I made a mistake there. That's true. So I'm comparing this with that. True, false, true, true, so that's true. False, 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 true. Okay, so that's the way it works. And then the second one, I've got P, Q, not P, not Q, and then I've got not Q, then not P. So we have true, true, false, false, true, false, true, false. Not P is false, false, true, true. Not Q is false, true, false, true. And then we do this, then that. And the only time that it's not true is if this is true and that's false. So we got true, false. That's the only one that's false. All the others are true because we either start with an F, which means we are true, or we have two trues, which is true. So we get true, false, true, true. True, false, true, true, and then we compare these last two columns, and you can see that they are not the same. They're actually opposite each other, so they are not equivalent. Okay, so we're going to stop there on this one.